We want to find the region between the sphere that's described by x squared plus y squared plus z squared equals 19 and the hyperboloid described by z squared minus x squared minus y squared equals 1, specifically for z greater than 0, which means we want to be above the xy plane. So we can take a look at this quickly in Mathematica, and that's what she looks like right there. Here's some code if you're interested in the Mathematica code. And I have this sphere and I have this hyperboloid. The hyperboloid actually comes down like this and up like this. So I'm looking for the area or the region between the sphere and the hyperboloid. And to possibly give you a little bit better idea, let's go ahead and kill that real quickly here. And you can see what I mean here by the hyperboloid coming down like this, and then that sphere is going to come up like that again. And then there's a sphere. So I'm looking for that region, that volume of that region right there. Okay, so one of the first things I need to do is I need to figure out where the sphere and the hyperboloid actually intersect. So I'm going to basically solve the system of equations here. I'm going to have z squared plus x squared plus y squared equals 19, and z squared minus x squared minus y squared equals 1. This do like we'd normally do to solve the system of equations. I'm going to add these things together. When I do, I get 2z squared equals 20, which implies z squared equals 10. So z equals plus and minus root 10. And let's see, if I let x equals 0, that will give me z squared is 10, so I'll have 10 plus 0 plus y squared equals 19, which means that y squared equals 9. So y is equal to, sorry, I kind of crunched that in, plus and minus 3. If I let y equals 0, that's going to give me 10 plus x squared equals 19, which means x is also going to be plus and minus 3. Now, I specifically used the first equation to solve these, but it didn't really matter. If you do the exact same with the second equation, you get the same solution. Now, the reason I solved for z like this was so I could substitute back in the numerical values and figure out what x and y are. Now, this is actually the sphere part, so I want to think about this in terms of the fact that this would imply that z equals the square root of 19 minus x squared plus y squared. See, that's going to define this top surface up here for me. And this also implies that z is equal to the square root of 1 plus x squared plus y squared. So if I change this to polar coordinates, actually spherical coordinates, which is polar coordinates with a slight twist to it, notice that this x squared plus y squared, that is r squared. So I can rewrite this as z is, well, let me scribble that out. The lower bound, because this is the hyperboloid, the lower bound is going to be the square root of 1 plus r squared. And it's going to go clear to the square root of 19 minus I squared, so r squared. So that's going to be the boundaries on z. And in looking at x and y, it's going to plus and minus 3. So I can think in terms of the radius. I was going from positive to negative 3, which means the radius is actually equal to 3. So if I set out my integral with respect to z, I can go from square root of 1 plus r squared to the square root of 19 minus r squared. That takes care of dz. And then dr, that radius, is going to go from 0 to 3. And then, of course, I need to think in terms of theta. Well, I'm going all the way around, so theta will go from 0 to 2 pi. And, of course, to switch to polar means I need to put that r in here. And it's not necessary, but if you want to, I'm going to put the 1 in, because that's kind of a reminder that when I integrate this triple integral with a function of 1, what I'm getting is the volume of that region. So, like usual, let's go ahead and take this first piece with respect to z. And what I'm going to get is, integrating with respect to z, I will get r times z, evaluated from the square root of 1 plus r squared to the square root of 19 minus r squared, which is simply r times the square root of 19 minus r squared minus the square root of 1 plus r squared. Now see, I'm going to integrate with respect to r next, and that's going to make this pretty nice. I'm going to need that r for u substitution. So now I'm going to integrate from 0 to 3, and I'm going to write this, distribute this r, and I'm going to have r times the square root of 19 minus r squared dr minus the integral from 0 to 3 of r times the square root of 1 plus r squared dr. Now you may or may not have needed to break that up. I just think it's a little bit easier for explanation to break it up. So here I'm going to let u equal 19 minus r squared, then du, or let's just say negative du over 2 equals r dr, which is exactly what I have. Here I'm going to let u equal 1 plus r squared, then du over 2 equals r dr. So this is going to be the integral of u to the 1/2. Well, I'm sorry, negative 1/2 u to the 1/2 du. And this is going to be a negative 1/2 integral of u to the 1/2 du. Now notice these u's are different. I probably should have used like u1 and u2, which is not too late to do that. Just so that you understand, there are actually two different u's going on here. Whoops. So now integrating these will be the same, except for, again, it's u1 and u2, and that does make a difference when I put in what u actually is equal to. So this is going to be negative 1/2 times u to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. So the 2's are going to cancel. And this is going to be the same thing. This would be, well, I can't evaluate it yet. I need to substitute in the u. So this is a negative 19 minus r squared to the 3/2 over 3 evaluated from 0 to 3. Let's go ahead and finish up this left-hand side, then come back to the right. So at 3, that's 9. So this is negative 10 to the 3/2 over 3. At 0, this is going to be 19. So this will be minus and minus, so plus 19 to the 3/2 over 3. Then on this side, this will give me a negative, what was that u? Was it 1 plus r squared, right? Yeah. 1 plus r squared to the 3/2 over 3 evaluated from 0 to 3, which is a negative 10 to the 3/2 over 3 minus, a minus, that's plus 1/3. So now I need to combine these two, and I'll get a negative 2 times 10 to the 3 halves over 3 plus 19 to the 3 halves plus 1 over 3. And I'm just going to say that's some constant k. Because now that I have that constant, now obviously there's no variables in it, I need to do this last integral with respect to theta. And that's just going to be 2 pi, because it's going to be theta evaluated from 2 pi to 0. So actually, I can just cut right to the answer and not even mess around with this. This will simply be this whole thing multiplied by 2 pi, which obviously can be reduced. I'm really running out of room here. Let me go up here for a second. This is a quick reminder of this 10 to the 3 halves. Well, that's the square root of 10 cubed, so that's 10 root 10. So I could write it like that. And obviously this is also going to be 19 root 19. So I mean, there's a few things you can fit around with, and obviously the denominator is the same, so you can put them all together and so forth. But essentially, there's the answer right there.